Hey, as software engineers, why do we use Big O?
So it's a big answer, but I'll try to summarize. The better question to ask here is, how do we actually calculate efficiency of an algorithm? Generally, we only care about two things. Number one is space complexity, also known as memory complexity. Number two is time complexity. And no, before you say it, you cannot calculate time complexity with the help of your stopwatch, because how much time your code takes to run on Intel i7 versus Intel i3 is going to be very different. So to solve this issue, we use Big O notation. It can objectively describe the efficiency of our code without using units like seconds or milliseconds. And it also gives us a result based on the size of input, because sorting 3 numbers versus sorting 100,000 is very different. And as good engineers, you always prepare for the worst case scenario. So now that you understand the basics, don't forget to subscribe so that you can actually understand how to calculate these values. So let's take a simple example to understand what Big O actually is. The goal of Big O is to tell us how our code is going to perform when the input size increases. Let me explain it to you in layman terms. Let's say you go to a car wash and the car wash takes 10 minutes for each car. Well, now we have a basic idea of how much time is the car wash going to take for 10 cars, or 20 cars, or 50 cars for that matter. Therefore, we can conclude it's a linear relation between number of cars and the time it takes to wash all of them. And here you can clearly see how this would be represented with the help of a code. There you go. And here the Big O notation is going to be O of n, and where n is the number of cars. So if it makes sense, let me know in the comments down below. And in the next video, we are actually going to take more code related problems and we'll find complexities for all of those. So follow for that. So a lot of people have this question about why we always want to measure the worst case scenario in Big O notations. Let's see this example. We want to find the word Joey in this array, and very conveniently it's placed at the first index. So how much time was it going to take us to find the word Joey? Well, it will be O of 1. It will be very first attempt, and that's the best case scenario. In all of the scenarios, when it's on position 2, 3, or 4, we can say it's an average case scenario, but that's not what we're interested in. We're interested in the worst case. So we'll put it in the end, and we'll say that no matter how, no worries. And we'll say no matter how big the array is, the worst case scenario is O of n. Why? Because let's say there are 5 elements or 100 or 1,000. The worst case is that we will take 1,000 attempts if we had an array of 1,000. So we can say the worst number of attempts is going to be n. Therefore, the time complexity is O of n. Simple, right? Let's take a basic example today. What is constant complexity, or what is O of 1 in terms of Big O notation? Well, you can see an example here. No matter what's the length of this array, it can have 3 students or 3 million students. This code is only going to run once, and it does not care about the number of students in the array. Therefore, the complexity, especially the time complexity, it takes this code to run is O of 1 because it's constant, does not depend on the input size. That's what constant complexity means. I hope you understand it better now, and let me know in the comments down below which is the next Big O notation you would like me to explain. A lot of new and experienced developers sometimes don't know what is O log of n. Before I explain this to you in terms of time complexity, you need to understand what log of n is, or what log is in general. Let's take this example. 2 to the power 3 or 2 cube is equal to 8, right? Therefore, we can say log to the base 2 of 8 is equal to 3. Now let's take this code as an example. Here you can see each time our for loop runs, our list for our n is divided by half. In the beginning, it started with 16, then it went to 8, then it went to 4, then it went to 2, so on and so forth. And then it finally stops. It is evident that our code is going to run 3 times when n is equal to 8 and 4 times when n is equal to 16, so on and so forth. Hence, we can say the complexity for this is log n. And the great thing about log n is it slows down with time. And for very huge numbers, it's almost constant, therefore making it one of the best efficient solutions for a problem. You might have heard about binary search. Well, it's log of n. I hope it makes sense to you, and let me know in the comments down below if you want me to explain any other time complexity. I'll be happy to do it. All the best.
Now, most of you know that when we're talking about time complexities, you're supposed to drop all the constants. But did you know that you also have to drop the non-dominant terms? So therefore, it means if you have a time complexity which is O of n square plus O of n, well, the answer is O of n square. Let's take a few more examples to bring this concept home. The first one you can see here is O of n cube plus n square. What would be the answer? It's O of n cube because it's the most dominant term here. What about the second one, which is O of n plus O of log n? Well, obviously now the answer is going to be O of n because log n is very fast. Now, it doesn't matter how complex the equation is. For example, in this one, the time complexity is going to be O 2 to the power n. Now, here's a tricky one, O of b squared plus a. You cannot remove any term here unless you know what is a as compared to b. Unless you have more information about this, you have to say that it is O b squared plus a. You cannot remove anything here because you do not know which is the more dominant term. I hope it makes more sense. All the best.
So when we're talking about time complexities, Do you know when you should multiply versus add? Let's look at an example here. Which one of these do you think is A plus B versus A multiplied by B? If you look at the one on the top, we have two for loops over here. And it says that when the first loop is complete, only then start the second one, which tells us that it's O of A plus B. The second one is more like for every time A runs, the complete B loop will run. Therefore, telling us that it is A multiplied by B. I hope it makes more sense to you now.